In October 2023, a highly unusual storm, Storm Babette, affected the British Isles, bringing catastrophic flooding to many locations. In this video, we're going to examine the River of South Esk in eastern Scotland and have a look at how the storm brought flooding to that particular area. This is the town of Brecon that was affected by flooding. Here is the river over here. And this is a flood wall that's meant to protect the town from this kind of flood event. You can see that it was overtopped, and indeed it is broken entirely here, allowing the floodwater to come in, and you can get a sense of the depth of that floodwater that has come in and affected many parts of the town itself. This photograph, I think, is quite a powerful one. When most people were evacuated, it was a mandatory evacuation order because the Met Office knew this storm was coming. But this woman obviously either couldn't or didn't evacuate and is left looking out with despair at the flood events and effects all around her. So let's start off by getting a sense of the river itself. Here we have in eastern Scotland, South Esk. We zoom in here a little bit, we'll see the drainage basin. We can see that the river rises here to the west in the Grampian Mountains, the steep-sided valleys here, which is one of the reasons why we had such significant flooding, as we'll see, flowing then down towards some of the lower areas in the towns, such as Brecon that we've just had a look at. So we've got to take a look at the physical and human causes of flooding on the way through. This is a little schema that we'll connect back in with on the way through that'll just help us organise our thinking. So let's jump in first of all to the physical causes, and there are two of those. And we start with looking at the very heavy rainfall that occurred, really unprecedented. This was associated, as I say, with Storm Babette. Babette formed west of Portugal over waters that were about 2 degrees warmer than average as a result of climate change. This meant that the air above could absorb more water from the sea, bringing a lot more moisture towards the British Isles. This is Storm Babette on Monday. This is the day that it was named, off the west coast of Portugal, here over the sea. And if we have a look at this map, which shows the sea surface temperature anomalies on the 16th of October, well, what that means is how much warmer or colder the sea is than would be average for this time of year. And you can see here the temperatures, if we look at the key, at least 2 degrees warmer than would be average, and over here, including in the Bay of Biscay, we're talking about the kind of heat that gets a lot more moisture into the storm before it tracks further north. And this was the route that it took then over the Bay of Biscay, picking up a lot more moisture and then heading on the Wednesday towards England. And the first place that it brought that rain to was the southern part of England, bringing some flooding there. It was a named storm, as I said, on Monday the 16th, and as a result, a very rare red weather warning was issued for rainfall. And this is only the fourth time that the Met Office has issued one of these for rainfall before. This was the little map that they released in this area here, where you've got the South Esk. They knew in advance that this area was likely to experience a lot of very significant rainfall. And part of the reason for that is because Babette got stuck. Depressions usually travel over the British Isles in less than 24 hours, but Babette was trapped over the UK by this blocking high pressure system that just was sitting here. There's the high pressure. The air circulating there meant that Babette couldn't keep moving further north and was trapped over Great Britain for about 36 hours. This brought nearly 3 days of non-stop rain. Wedge Day, are you ready for this? 160 millimeters of rain in 24 hours. Now, always whenever I'm quoting some values in millimeters, kind of the values, the units themselves don't really carry much of a sense of wow. So let's rephrase that in a way that maybe will be a little bit more tangible. That's equivalent to nearly 2 months of rain falling in one day. That's what 160 millimeters of rain in 24 hours means. And let's watch this moving forward. So this is on the Monday. It's just been named Storm Babette, picking up a lot more moisture over the warmed oceans here, warmed by climate change. As it moves further north, this is the Tuesday, over the Bay of Biscay, still picking up the moisture. And by the Wednesday, it's now bringing rain to the southern part of the British Isles. Then the Thursday, in comes the rain to Scotland. This is the high pressure to the north. There's no cloud there. That gives an indication as well. But it's also acting to block the storm. It can't travel further. So let's see how far north it gets by the Friday. Hasn't really moved much. And by the Saturday, still stuck, maybe just nudging ever so slightly further north, but still bringing a lot of rain over Scotland. And it was only into the Sunday that it battled enough to get further north. We had those non-stop days of rain pummeling this eastern part of Scotland. This brilliant graphic by the Met Office shows the rainfall totals building up. You can see on the Thursday, many parts of the United Kingdom being affected. A lot of peaks down there in England. But look at Scotland. Look at those rainfall totals going up. Babette is stuck over the top. It is raining relentlessly day after day, bringing all of those rainfall totals going up and up and up. Over 175 millimeters. Months of rain falling in a day over this area. It's absolutely staggering, those totals. Very, very unusual and unprecedented. There's our little area. So, the physical causes of those very, very heavy rain that we've just seen associated with Storm Babette. The second one is where that rain fell. It fell onto an area that had very, very steep topography. That's the shape and height of the land. And the channel capacity of the rivers were quite reduced. So there's the topography. That's a very steep sloping in the upper part of the river. Let's have a look at this. We come down here, very, very steep sloping topography. And as we zoom into the upper part of the drainage basin, and I've even turned on a little bit of rain to give us a sense of what that would have been like. All these steep-sided valleys, the rain just falls there and very, very quickly travels down the steeper hills into the river channel below. And that channel just funnels everything down towards the lower ground. This is called a spate river, S-P-A-T-E, and it just is a river that gets water down from the upper part of the catchment to the lower part very, very quickly and very, very efficiently. We can also look at this using our Ordnance Survey maps. The contour lines here representing the steepness of the land. The closer together the contour lines, the steeper the land. You can see here just how steep the land is surrounding the South Esk. In fact, if we use this GIS map and travel from the source, here's the source here. Travelling down, there's South Esk running along here. You can see that for many parts of the upper catchment, just how steep that is, how close together all of those contour lines are, just funneling the water down, funneling the water down, funneling the water down. What does that look like? It looks like this. So that's the upper part of the catchment of the water being funneled down very, very fast. Also, unusually, the storm winds approach from the east. We typically get our winds approaching from the west in the British Isles. The prevailing winds, the most common wind direction coming here from the west. But because of this high pressure system here, rotating around in this clockwise direction, it funneled the weather and the winds in from the east, bringing a lot more rain to the eastern part of Scotland than would typically be the case. The eastern part of the Scotland is normally in what's called the rain shadow effect, giving less rain there. And this is the average October rainfall from 1991 to 2020, that 30-year period that we take climate over. Here is the South Esk. So if we take a line across here, we can see that in the western part, we've got values over 250 millimeters of rain falling. And as you move across here, the values get lower down to between 60 and 80. So between 4 or 5 times more rain here in the western part of Scotland than there would be in the east. The eastern part of Scotland is normally a lot drier than the west. And the reason for this is related to that rain shadow effect that we talked about. The winds that are approaching typically from the west pick up moisture over the sea. Then the winds are forced to rise. They cool and condense, and that releases a lot of rainfall out into the mountains here. So imagine, if you like, a big sponge that you plunged into a bucket. It is sodden with water. Then you lift the sponge over the mountains and you give it a good squeeze, and the mountains absorb most of the rainfall here. And by the time you get over to the other side, there's just a lot less rain, or a lot less water in the sponge for you to squeeze out. They are also sinks and warms, means that there's less likely to have rain, and that produces the rain shadow effect here typically in eastern Scotland, where the South Esk is. Now, as a result of that, because the rivers here are used to getting a lot more rain, the discharge is typically higher, there's a lot more energy, and the rivers erode more. The rivers are deeper, the rivers are wider, the rivers therefore have more capacity. There's more space in the rivers to hold the rain that falls. Whereas over here, because there's typically less rain, there's typically less erosion, the rivers aren't quite as deep, aren't quite as wide, they don't have the same capacity. Consequently, whenever all of this incredible amount of rain, 2 months worth of rain falling in a day, staggering totals, the South Esk River channel simply was not big enough to cope with the unprecedented rain from Babet. So the very heavy rain, the steep topography, the limited channel capacity meant that the river levels rose very fast. Look at this. This is from North Esk, a river just to the north, but it shows very, very powerfully how fast those river channel levels were going up as a result of the rain that was coming down. Or we can see it in this graph, this hydrograph, showing the water levels in the river going up from around about 0.15 up to 1 metre, 2 metres very, very quickly. And it kept on rising until it got to around about 3.4 metres whenever the river gauge, which measures the amount of water in the river, broke because of the flow of the river. We know that it got up to around about 4.4 metres because it came over the top of the flood wall like this. Absolutely unprecedented rain. It's just as well that there was an evacuation ordered there, because the people that were had they stayed in there would have been at grave danger and risk. So now let's move on now to take a look at the human factors. Human factors don't directly cause the flooding, but the flooding that would happen anyway can be made worse because of some of the human actions that have been taken. And we're going to take a look at 2 of those: overgrazing in the upland areas, and then particularly the failure of the hard engineering management in Brecon town. So what about overgrazing, first of all? The land use in the upper drainage basin is mostly rough grazing on moorland, which is covering around about 44% of the drainage basin. And this has been overgrazed by sheep. So that means that, hello lovely little sheep, I'm sorry, we're going to say some naughty things and nasty things about you, but those sheep that are just doing what sheep are naturally doing, they tend to overgraze, and therefore any rain that falls onto the land, there's less interception of that rain, and therefore it gets down to the river channels faster. The natural slowing effect of the vegetation is reduced because of the land use and the farming that's taking place in this area. Listen, with those steep slopes, it's going to come down here fast anyway. This naturally is a spate river, but the human actions are amplifying that and making that worse. It's our overgrazing. The second human cause is the failure of hard engineering and the management of the river. The main management defence in Brecon town was this flood wall. The town relied mostly on this 1.7 metre flood wall that was built and completed and rebuilt again in 2016. That was as recently as it was done. And a series of proposals for other soft engineering methods to work alongside it have actually been rejected, surprisingly. Here's one from an assessment of the flood mitigation options. This is a paper that looked at a whole variety of different ways, including some soft engineering methods that could have been used to help. And this one in particular I want us to look at is the washlands, this area upstream of the river that was proposed to be used as a natural store of river water if it was flooding, rather than going into the town. But this was rejected. Here's the reasoning. The capital and operation maintenance costs and the long-term effects on the environment. So because of economic and environmental reasons, they decided not to do this. Now let's have a look at this on this GIS map. So if we have a look here, I'll just move that in towards the side. And this is the river itself. You can see here the rising and the very steep area in the source. But we want to come down here to Brecon itself and the rejection of that flood management. So let me just turn off this, and I'm going to turn on this area over the rejected washlands. We'll also change the base map here so that we can see a little bit more of where the settlements are down below. So I'm going to come down here to OpenStreetMap, and we'll see there is Brecon. Let me also just turn off that layer of the drainage basin. So there's Brecon itself, and there's the river flowing in beside it. And this area, this just upstream, was being proposed as a natural store. They were basically going to put a sluice gate on there, which would have partially closed, allowing the flood water to build up here rather than further, just heading further downstream. So the idea is that the water as it's coming downstream is stored here rather than coming down and flowing into the town down around about here. That's a very classic soft engineering strategy, and as you see from that paper that we just looked at, they rejected that on economic and indeed environmental costs. Now the question is, was that a little bit short-sighted because of the economic damage caused by the flooding down in this part of the town? Should they have introduced some soft engineering alongside the hard engineering? Arguably, yes, you may want to say. So this is what they were reliant on. This is now down into the town itself, and this was an area here where they had some soil embankments and an area here with flood walls, and this was the area that ultimately flooded. So a little bit of street view here to show you this. The embankment in the background there, and as we come down here we can see the flood wall that was built to try and protect the town. The river is sitting in down behind that, so the flood wall itself is about 1.7 metres high, but it's around about 4 metres above what would be a typical level with the river. It's designed to increase the capacity of the river and to really just keep the water in there and not coming and affecting the town. That's what they were reliant on. There was no additional soft engineering that had been rejected, and unfortunately the flood wall alone could not protect the town from flooding. I wonder, can you see the river here? Have a look. Can you spot it? This is an aerial view of the place that we've just been at with Street View. Here's the river, and up here was the flood wall where it overtopped. We were just literally down here at Street View. So this flood wall overtopped, and it broke and breached at that area, and the flood water just came into this lower part of the town all around about here. And these areas were all catastrophically flooded because instead of holding the water back upstream a little bit, there was nothing they could do, and the flood waters that rose at that unprecedented levels just came over into the town itself. The flood walls were not enough. Additionally, we could criticise the Scottish Environment Protection Agency because they didn't factor in sufficiently the impact of climate change. These flood defences in Brecon were last updated only in 2016. And then in 2021, SEPA report, Scottish Environment Protection Agency report, reckoned that there would not be a major flood in the town until the 2080s. Only 2 years later, the authorities were proved wrong. They underestimated the effect that climate change would have of supercharging these storms. So this is their 2021 report. The latest science on the effects of climate change predicts that parts of Scotland will experience wetter winters and more extreme weather events, they said. In November 2020, SEPA published flood maps, future flood maps showing the impacts of climate change in Scotland for the first time. And these maps are based on the 2080s high emissions scenario. By the 2080s, if we have high emissions and climate change carries on, what is the likely flood risk that could occur? Well, here's the map itself. So if we take a wee look over here, this is the high likelihood of flooding, the kind of flooding that's going to occur regularly. And what you can see here is that the town is largely protected. But what about that low likelihood? What about the kind of flooding that's going to be possible only by the 2080s? So they thought. We turned that on and you can see that the flood defences, the flood wall was nowhere near enough to protect for what they thought was a low likelihood flood event, what they thought would only be occurring by the 2080s. And they released this report in 2021. And by 2023, that quote-unquote low likelihood flood event has already happened. Have they taken the risk of climate change seriously enough? Well, according to others, no. Get used to it. Experts warn Scotland is Storm Babette weather likely to become the norm as climate change ramps up. So the human causes don't directly cause the flooding. The physical causes do, but they amplify it. The overgrazing, the land use reduce the slowing effect of the natural vegetation, and the reliance on hard engineering rather than soft engineering, and the lack of factoring in the effect of climate change in the management decisions meant that the river levels rose and flooded the town of Brecon. So to summarise, the floods of South Esk in 2013 were related to very heavy rain, related to Storm Babette that was supercharged by the warmer than average rainfall that got stuck over the British Isles, bringing continuous rainfall for about 3 days and 2 months of rain falling in 24 hours. Absolutely unprecedented. Secondly, the steep topography. It fell on very steep land, which is going to funnel the water down quickly, and because it came from the east into river channels that have lower capacity typically, because our rain typically comes from the west, there wasn't the capacity in the river channel in South Esk to hold it, and the flooding occurred. The river levels rose very, very fast. The physical causes were enough to cause the flooding anyway. The human causes amplified it. The overgrazing by sheep in the moorland up above in the upper catchment meant that the natural slowing effect of vegetation was reduced, and the failure of flood management because the reliance on hard engineering alone, not soft engineering, and the lack of factoring in of climate change meant that river levels rose and flooded Brecon. So those are the causes. I think there's some salutary warnings in there for us as we think about how we're going to live in a world where climate change and its effects are becoming increasingly a reality. How are we going to adapt to those? We need to take the threat seriously. We need to make sure that our places and our homes are protected against the risks of flooding that are going to be amplified by the effects of climate change. This storm should serve as a warning to us. I wonder, are we listening?